Today we are combining like radicals, and honestly this looks a lot more confusing than it really is. In this first little example, we've got 2 times the square root of 3 plus 5 times the square root of 3. Because the square root of 3 and the square root of 3 are exactly the same, we can add the 2 plus 5 to get 7. Basically, it's 2 chocolate chip cookies plus 5 chocolate chip cookies equals 7 chocolate chip cookies. It's also the same as 2x plus 5x equals 7x, but instead of an x, it's a square root of 3. So in number 1, I've got 3 times the square root of 2. What can I combine 3 times the square root of 2 with? Negative 2 square root of 2. 2 times the square root of 3 can be combined with 3 times the square root of 3 because those radicals are the same. And the square root of 5 doesn't have any friends. It can't be combined with anything. So 3 square root of 2 minus 2 square root of 2 is just 1 square root of 2. 2 square root of 3 and 3 square root of 3 is 5 square root of 3. And then we have the square root of 5. In number 2, we're not actually going to do all of number 2. I just want you to notice for a radical to be the same, it has to be the same index and the same radicand. So cube root of 3 can be added with cube root of 3, but square root, or cube root of x and cube root of x, square root of x and square root of x would have to be combined together. I would like you to try number 3 on your own. Pause the video, try number 3 on your own. You should have gotten 4 times the 4th root of 5 minus 7 times the 4th root of 13. Notice when I highlight each one, I highlight the term and the symbol that comes before it. Remember to attach those symbols to whatever comes after the symbol. So here's the problem in example 1. These radicals are not the same, so we cannot add or subtract them. So we need to take the square root of 48 and simplify it. Remember, when we simplify it, we are trying to split it into a perfect square times something else. The problem with the square root of 48 is that the first number people come to is 4. And yes, 4 works. Whenever 4 works, I want you to try also using 16. See if you can do that number divided by 16. Because the square root of 48 splits into the square root of 16 times the square root of 3. So this is 4 times the square root of 3. But we can't forget that there was a 3 in front of that term before we simplified the square root of 48. 3 and 4 are both not under the radical. That term becomes 12 times the square root of 3. Now we need to simplify the square root of 27. How can we split up the square root of 27? And do you notice when you split it into 9 and 3 that the previous problem that we simplified gives you a hint about how you need to simplify this? If the first one ended up with something times the square root of 3, we're probably going to have something times the square root of 3 again. So that will help you to figure out what it needs to be. So this is 3 times the square root of 3. Don't forget that there's a minus sign. So now we have 12 square root of 3 minus 3 square root of 3. So the answer is 9 square root of 3. We're going to skip example 1b and move on to example 2. In example 2, first let's look at A. We have 7 times the square root of 80 times the square root of x. We'll leave the 7 and the square root of x alone. We need to simplify the square root of 80. I know that 4 works. I think it's 4 times 20. But if 4 works, we should always try 16. 16 times 5 is 80. So we can split the square root of 80 into the square root of 16 times the square root of 5. We didn't do anything with the 7, but it's still there. We didn't do anything with the square root of x, but it's still there. We need to put this together into one cohesive term. So 7 times 4 is 28. And then we do square root of 5x. Let's do the exact same thing. I'm also going to stick the minus in right now so I don't forget about that minus. We have 2 times the square root of 125 times the square root of x. We need to split up the square root of 125. We can look back at the previous problem and know that it's probably something times 5. It's 25 times 5, and 25 is a perfect square. Don't forget about the 2 that we didn't touch, and don't forget about the square root of x. This one becomes 10 times the square root of 5x. As long as the entire, whatever comes after those first numbers, as long as it is the same on both of them, you can do the math. What is 28 minus 10? 18, and then we put that square root of 5x on the end. Okay, example B. I'm assuming that you look at example B, you see the fractions, and you start to like panic a little bit in the pit of your stomach. Your work might be a little confusing on this, but these really aren't any more difficult. So I know that I have the 6. We need to take the square root of 24 and simplify it. So I'm just going to bring this over here and simplify the square root of 24. How can we split up the square root of 24? 4 and 6. So 2 times the square root of 6. So on the top of this thing, I have 2 times the square root of 6. Now let's think about the bottom of that thing. The square root of x to the 4th. How many groups of 2 are there in 4? 2. So that's just x squared. So we have x squared on the bottom. Now, in this crazy looking term, what 2 numbers are we allowed to multiply together? The 6 in front and the 2 that's in front of the radical. So this term becomes 12 times the square root of 6 over x squared. There's a minus sign. Now we need to do the same thing with the other term. We've got 3 times, if we take the square root of 54, we can use the other problem as a hint. I know this has to split into a perfect square times 6. 9 times 6. So we have 3 times the square root of 6. And thankfully, the bottom is again the square root of x to the 4th, so we know that that's x squared. So that term becomes 9 times the square root of 6 over x squared. This one looks more like snickerdoodle cookies to me. I don't know about you. We got 12 snickerdoodle cookies minus 9 snickerdoodle cookies, so how many do we have? 3 snickerdoodle cookies. Take a look at example 3 and think about which of those examples looks the most difficult. We'll tackle the most difficult one because then anything that's simpler than that will be cake. They're honestly both the same difficulty, but B looks more, so we will do B. I'm basically just going to split my work into 3 little areas just so I can kind of keep everything contained. So first of all, we have the square root of 48 and the square root of x to the 5th. So we need to split up the square root of 48.
6 and
6 and what?
8.
6 and 8 aren't perfect squares.
Oh, yeah, we put it in.
I know 4 works. If 4 works, what other number should we try? 16. 16 times 3 is 48. So we have 4 times the square root of 3. Square root of x to the 5th. We're looking for groups of 2. We have 2 full groups of 2, so that's x squared, and 1 left over. Let's make that a nice cohesive thing. That would be 4x squared square root of 3x. Okay, on this next one, we have 2x that we're not going to do a whole lot with. We need to break down the square root of 27 and the square root of x to the 3rd. Square root of 27. Yep, 9 and 3. Square root of x to the 3rd. That would be 1 full group of 2 with 1 left over. And don't forget we have the 2x that was in front of the problem originally.
Multiply.
We can multiply. We multiply the 2 and the 3 to get 6.
X squared.
And then x squared, because there's the x here and an x over here. And then square root 3x. Are you starting to notice what's happening in our answer? X squared square root 3x, x squared square root 3x. Okay, something nice happens in the 3rd part. What do you notice about the 3rd term?
I think it's going to be x squared 3x.
See how it's...
Oh, it's already there.
It's already there. It's already done. Okay, what this problem is trying to show you is that there can be stuff in front of the radical. There can be fractions. There can be all sorts of things. But if you've got 4, 6, and -3, as long as whatever comes after the 4, the 6, and the -3, as long as those things match perfectly, you are good to go. So we have 4 plus 6, which is 10. 10 minus 3 is...
7.
7. 7x squared square root of 3x. And that is your final answer.
Sounds sweet.